Good morning. It is Thursday, the day before Halloween. It's about 5:30 a.m. You guys probably saw the note on the board. Scotty's like a walking bacteria trap. So I'll be out this morning. If you really need help, I'm planning on coming in for probably after lunch for the last half of the day. My wife will come home and we'll switch. So otherwise, I know we had lab planned today. That kind of bites, but not a big deal. You guys need to practice anyway, and this will give you a chance to do it in school and not out of school. So just big picture, get your packets out and stuff. Whoever the sub is can feel free to pause this as necessary, but I kind of left notes on the board. What we've done so far is introduce chemical reactions and the different types. In our class, we've really talked about synthesis, decomposition, and single replacement. Those are the main ones. I think I kind of led into double replacement a little bit, but I'll lecture more formally over that next week. But review your notes. Make sure on, I believe it's page 7, we're talking about synthesis reactions and how it's either very, very simple or you use your pink sheet to figure out how two simple things can make one bigger thing. Or in decomposition, we have one complex thing breaking down into its parts. And again, if it's one of those ones that you don't know, or it's a little bit more complex and there's like 3 people in the couple, use your pink sheet to figure that out. That practice would be on page 11 for those. I'll talk about that in a little bit, but otherwise I was just going to do 1 or 2 more of the practice ones we left off for single replacement that I thought were important we wrapped up. So single replacement reactions, I think this is on page 7 in your notes. We talked about how a single element replaces one and another one if it's more handsome. I believe I shared some very personal memoirs with you guys, and there's more to come on that because I ended up besting Joe in the long run. But we had done a couple of these. We're using our activity series. One of the ones we had skipped was number 14. So practice problem 14, everyone, is when you drop sodium in water. We've all seen this video. I'll show it again when I come back. But we know that explodes, that reactive alkali metal. So if we really go and jump into the reaction, I'll really encourage you to keep making sure you're writing the charges when you need to. So your final answer in a minute here, like in the bottom, that can't have the charge, but when you're going through and trying to figure out the work, it's like you analyzing, it was like Paige analyzing, oh, Jake could be a +1, he could be a +2 or whatever. But we'll have sodium, which we know will be +1 in a compound, is dropped into water. Now, if we look at the board, this is a single element sodium with a compound water, so that fits our single replacement reaction type. And when we go to think about it, we know that what would ended up happening is that oxygen's negative, sodium's positive. Most kids are going to end up taking sodium and putting it with oxygen, which is wrong. That would leave hydrogen by itself, so don't write this. This is wrong. This is actually one of the most missed questions we have. So that's not actually what happens. I know it looks like it would, but what we learned yesterday was that water is a little bit more complex than just H and O. So when we go to really look at water, we can't just go and jump and slap that sodium and oxygen together because it's a little bit more detailed as far as how it really happens. So when we go to look at water, we talked about this a little bit yesterday when we were balancing. Water is really kind of breaks down into that hydrogen ion and that hydroxide as far as the way it's actually going to bond. Now, if you go to look at this looks a little bit more like what we did yesterday. So here's that Joe kid, here's me, and then here's Paige. So if I asked you here, the question I always ask on single replacement is who has the choice? We have a positive, and a negative. The choice there would be with the negative. And the negative has to choose, is she going to choose to stay with the positive hydrogen, or is she going to choose to go with the positive sodium? I don't expect you to memorize how to do that. I expect you to know how to use your tools. So if we get out our little pink half sheets, which you can always use on quizzes and tests, we go and we look at that and focus on the metal list, and we can see sodium's pretty high up, hydrogen's pretty ugly, so that would definitely tell us that hydroxide would way rather go with who's more handsome, which would be sodium. So you can see here that sodium really isn't going to go with oxygen. That's kind of that most missed question we talked about. What it's really going to do is go with hydroxide. And then somebody will be left by themselves at the dance crying. So what that's going to end up looking like when we go write it neatly is Na. Again, it doesn't have a charge yet. And I have no problem if you want to write water as HOH. I think that will help a lot of you not make that mistake, because then you can really see that sodium is not just going to go with O, it's going to go with that hydroxide. So when that really happens, we're going to have Na, which is +1, hydroxide, which is -1. We know that that's going to make a 1-to-1 ratio and be sodium hydroxide, and then make sure when we go to have hydrogen left by itself at the dance, that's what's really going to make the explosion. It's not just going to be H, it's going to be H2, because that's that diatomic gas. That rapid production of that gas is what makes the reaction itself explode. So otherwise, we're writing dashes in the front because we know that that'll help us remember to balance it. So we start with our metals, and again, we got to be careful here because we have multiple places of hydrogen. So we have 1 sodium and 1 sodium. That's all good. When you go through it, the mess becomes you have a hydrogen here and 2 hydrogens here. So that makes 3 hydrogens. We can't get water to have 3 hydrogens. So like I talked about yesterday, if we have an odd number, just get it to an even number and roll with it. So if we were to add a 2 in front of this, that now would make 2 hydrogens here and 2 hydrogens here, which would make 4 hydrogens. I can get water to have 4 hydrogens because if I put a 2 in front of it, 2 H2Os would have 4 hydrogens, which is awesome because now I have 2 oxygens and I have 2 oxygens. Then just remember we changed the sodiums to 2, so we have to go back and make sure that when we start out, we start with 2. So I know that that's fast, but you just need to practice it. The practice you'll be doing for your balancing is that page 10, okay? So that was one I skipped yesterday. The other one that I didn't do just time-wise yesterday was practice problem 16. I'm not going to do the whole thing with you. I just wanted to point something out. So we're going to have chlorine gas react with sodium bromide. So it's really important we're careful here because the reaction has to have Cl2 because it's chlorine gas. We know that if chlorine, though, is in a couple, which is how that girl at the homecoming dance is going to predict it, we want to know what will it be. So we're going to have chlorine gas, which is going to be Cl2, but would be -1 in a compound, react with sodium bromide. So sodium's +1, bromide's -1. So, and again, you got to get better at, this page makes it easy because they're all single replacement, but otherwise you got to start getting good at, oh, I have a single element with a compound. I need to see if a single replacement reaction is going to occur. So when you go to look, I don't know if you guys noticed or not, but there's actually 2 Hansen scales. The 2 Hansen scales, the top one is for metals, the bottom one is for halogens. So if we really go look right here, we have bromine and chlorine, those are the negatives, and then sodium is the positive who gets to choose. And again, what it's going to choose is the more active element, the one that's more reactive. So if sodium has to choose between bromine or chlorine, it looks like chlorine is a little bit better looking than bromine. So she's going to dump this 5 rated boy she's with and go with the 6. So I'm not going to finish that one for you. I just wanted you to understand that there's another little Hansen scale there if you're dealing with halogens and a metal has to choose. So that was really all I wanted to do for notes. What I have on the board for the rest of class for you guys today is some practice. So I think what I wrote on the board after you've watched this video will be, you'll go to page 10 in your packet. That'll be balancing reactions and types. You should either pick the odds or the evens. I really don't care which. I don't think you need to do all of them right now. On page 11, that's synthesis and decomposition reactions. So synthesis and decomposition reactions, we just need to keep practicing. And again, I just break it down one problem at a time. And then page 13 had some single replacement ones. Like I think we needed some practice of that. I would say maybe on that, maybe even if you go do the evens, I think that'd be really good practice. And I mean, don't get thrown off. Like I'll flat out tell you, number 2 is one of those ones we practiced yesterday where it's going to be a no reaction, meaning the aluminum and iron are the 2 choices, and the oxygen there is already with the better one. So just make sure you're not assuming a reaction is going to happen. You need to make sure that you're actually going and looking at the chart and seeing if it will. So you guys know that the answer keys are all going to be on Canvas. So I mean, if you go in here, I mean, here's single replacements, here's the keys, here's old videos I made during COVID if you're really struggling. There's the reaction bell ringer stuff. I'll even just point out on the fly here, reaction bell ringer 2, a lot of kids are really struggling, I feel like, with synthesis and decomposition. So on this one you got a single thing getting heated up, and on this one you have 2 things synthesizing a new compound. Those are both ones where you're going to end up wanting to use your pink sheet, just because I wouldn't expect you to know how they work. So Otherwise, outside of those, I'm fine if you guys want to go in lab and work and be productive, but just make sure our phones should be away. We should be very, very productive today. So otherwise, you have your pink reactions assignments. Assignment 2 and 3 you shouldn't really mess with yet, but assignment 1 is all about synthesis, decomposition, and single replacement reactions. Just so happens that's what we've lectured. So on the top, you're going to go practice balancing it. You're going to write the type of reaction, and then underneath you're going to go do the word equation. So this would be sodium iodide plus chlorine gas makes sodium chloride and iodine gas, and just getting good at that translating thing. There's going to be just practice about the coefficients and you balancing it. I know it's a little bit messy on my computer, but it's just, I can't stress enough, that reactions assignment 1 should probably be done when you come in on Monday. You're going to keep working up on the problems. Like when you get to 11 through 15, you'll notice that's where I don't tell you what it's making. You have to go and ask yourself, is this two simple things synthesizing a new thing? Is this one big thing, number 15, one big thing being left on a hot plate? That's a decomposition. Is it a single element? Replacing another one, and use your Hansen scale? So what I think I'll end up doing then is probably giving you guys a good hour-ish. I might have told this up 10:25-ish or so. That'll have been a good hour of practice after the fire drill. I'll probably end up leaving reactions quiz 1. Again, a quiz is just a checkpoint, guys. So I'll probably actually just let you jump in and work with partners on this, but that's just going to be translating word equations into chemical reactions and balancing it, getting good at the types of reactions, the formulas, predicting what it's going to make, and again, I'm fine with that being with a partner just because it's our first one. So by the time you show up Monday, you should have that page 10, 11, and 13 done. I would say bell ringer 1 and 2 need to be done. That little naming sheet you can have just put in the basket, but I put the answer key up on the board. And then if we don't get the quiz done in class today, that's fine. But I think that practice of us being under pressure, having to use our pink sheets and stuff is really, really good. So answer keys and stuff are online. I'll still check my email this morning if you guys need something. So just let me know and be productive, and I'll be back Monday and we'll go through that lab. So thanks for being flexible, be productive, have a good Halloween and long weekend.